Let's make a new slip casting plaster mold for this form using these 3D printed parts. And I'm going to try a new method to join the mold together, in particular using this tape here. Hi, I'm Kent. I've been working on a new form for slip casting. In my last video, I worked on the design for basically a hybrid between these two forms here. I wanted something that was basically this height and width, but had these curves. And I used Inkscape to draw that form and Shapecast to go ahead and create it. And that resulted in this design proof here. This one has a nice swooped foot and a break here for the glaze. This one has something similar. I like printing out these design proofs so I get a sense of what the pot's like. And I'd actually done that for these others as well, way back when I made them. So how do we go from this concept into a plaster mold? That's where Shapecast comes into play. So probably the most important piece that gets created by Shapecast is this one here. So this has the exact same form, only it's been scaled up to account for clay shrinkage. And it also has a slip well. It gets printed in this orientation, basically upside down relative to the pot. And that's what all the supports are on the inside. I used the organic tree supports, and I went ahead and printed this on the fine setting on my bamboo printer. Overall, the surface finish looks really good. There's an artifact here where the seam line is, and the foot here has some artifacts in it as well. So there's some steps here that I can feel and you can see from the 3D print. And then there's the seam from basically when it changes directions. So we won't need to do much to clean this up, but we'll want to do a little bit. You could go ahead and put this into cottle boards and use a traditional mold making process. However, I found that rather tedious and annoying. So Shapecast generates several other parts. So it creates a bottom for the mold, which is in two halves, mostly so it can fit on your print bed, but also so it matches the outer mold. And that's what this is. This is the outer mold. This basically replaces cottle boards. So what will happen is we'll take the bottom ring here and attach the inner mold. Then we will attach the outer mold. And then we'll pour plaster in here. So that will basically let us make our plaster mold. It will get poured like this. So plaster will come from this side. The reason we're pouring it upside down is so any bubbles that are in the plaster will rise away from this surface here, which is the one where the pot's formed. You'll notice that Shapecast adds a whole bunch of features into these parts, and that's so we can attach them together in a watertight way. The plaster will want to leak out, so we need both a mechanical attachment as well as a waterproof attachment. When I was first building Shapecast, I tested a bunch of different things, and you can go back and see me building it. I have some videos from a while ago. What I wound up settling on is a neoprene gasket to act as the watertight barrier, and then threaded inserts and bolts so I could mechanically attach this together. And this has worked well. I've had 0 plaster disasters, which is great. And I like using the outer molds because the mold itself winds up just being really nice to handle. There isn't a bunch of excess plaster and it basically conforms to the shape of the pot. It creates a basically 1-inch thick piece of plaster, 25 millimeters. So it's nice and consistent and overall just pleasant to use. However, the threaded inserts and the neoprene gasket do take some work. So we can see all the features that are used for the neoprene gasket and for the threaded inserts. So basically there's a recess here in all the parts for the gasket to fit into and a bunch of holes for the threaded inserts and bolts. They're here, they're on this face as well, so we can attach it together. They're on the bottom here, so we can attach it to this ring, and then on the sides. The reason this is in several parts is that we need to be able to demold the plaster afterwards. We don't need our 3D print entombed in the plaster. That won't do us any good. And when I was doing very early testing, I wound up destructively removing 3D prints quite a bit, and that was really annoying. So having something that comes apart basically in as few pieces as possible is nice. The other thing is that we run into print bed limitations very quickly between the clay shrinkage factor, so we need to scale up, as well as the extra space needed for the plaster. Things get big pretty fast. So if you look at this outer mold here, we can compare it to our pot size, and you can see how much bigger the mold is relative to the pot that we want. And this is 2-scale finished size. This could probably be printed in one piece, but you really don't want this outer piece in one piece. I did a test again very early on where I did it in one piece and I wound up cutting it off, which was not great. One of the other advantages of doing this is that the mold is reusable. So if you're doing some production work and want to make several plaster molds, you can actually do it directly from the 3D prints. You don't need to use silicone or go through that process. If you wanted to make a whole bunch, maybe you would want to move into the silicone realm, but you can definitely do several plaster pours out of these same prints. So in addition to making a new plaster mold, I want to go ahead and try something different. So while the threaded inserts have worked great, I have been thinking about getting away from them. So I want to test using this here. So this is tuck tape. I've been using it for my handle molds. So here is a handle mold, or half of a handle mold. And I basically tape the seam together, tape this seam, and I tape the bottom handle piece in as well. And this has been working really well. People will often use this for resin pours, and it's basically holding back the resin. So resin tends to be rather liquidy, so it can flow through any cracks. So it should be able to hold the plaster back, and it's waterproof enough, I think, to last basically the time needed before the plaster sets. The threaded inserts and bolts are actually doing one more thing. They're acting as alignment, but because this is the outer mold, that alignment really isn't critical. Basically, all the key features are here in this mold here. So everything else is just holding the plaster back. So that will be the experiment in this video. Hopefully it works out and we'll have another way to make our molds. Next up is to go ahead and clean up our inner mold a little bit. And basically I want to do something similar to this. This has some plaster residue on it, but underneath the gray is actually a primer. And this one here is a different mold, and this one I used some spot putty on. I think I'll go ahead and try the spot putty and see how it works, because overall the prints are really good. There's a lot of comments on my channel about layer lines in the prints, and when you print on the fine settings, they basically disappear. So you can kind of spend as much time or as little time as you want, especially by the time you go through the whole process of creating the pot and it shrinks and you're using a sponge to kind of wipe things down. The 3D printed artifacts basically go away. I was doing a slip casting workshop here in my studio not too long ago and had a bunch of people come in and do slip casting for the first time, which was a lot of fun. And people did ask about the layer lines. And I showed them this bowl here. So this is actually a second. I was having some problems with my clay body and it cracked, but I think is a good example. So this one has a translucent glaze, so you can actually see through to the clay body. And I asked them, where are the 3D printed artifacts? And often what people will point out are these bands here, these vertical bands, but that doesn't actually make sense because 3D printing is printed horizontally. So if any layer lines would go this way. These bands are actually artifacts in the model. So this was created by a very early version of Shapecast. When it was revolving the form, it was doing it in a very coarse way. It's actually kind of a cool effect. I think I want to explore that a little bit more at some point. But that's not actually a 3D printing artifact. It's actually a modeling artifact. So if we look around, this here is actually the seam line that you can barely make out. So it's equivalent to this seam here. So that one did persist, and you have to basically flip it over to the foot. And here you can see some of the layer lines. And sometimes I'll sponge these out, sometimes I won't. So most of the artifacts really do go away. But if we clean them up now in the plastic, that means they won't transfer into the plaster, which means they won't transfer into the clay itself. So we can spend a little bit more time at this point and save more time later. So here are the materials that I use. So this is the primer. This is an auto primer. It basically goes on really thick. And the idea is that you want something thick so it fits in all of the valleys and you can sand off the ridges. People have talked about other types of 3D printing smoothing, and basically the trick is you need the high points to go low and the low points to get filled in. Whatever method you have that does that, go ahead and go for it. I like this one. And this is another automotive product, again, for painting cars. This one is a paste. Basically, you can rub it on and do the same thing. Since I think the print overall looks pretty good, I'm going to try this basically just to do the foot and to cover up the seam, similar to what I did with this mold here. So this is straight off my printer. I've done nothing to it besides remove some of the supports on the inside, and even those you don't really need to remove. I'm going to do a little bit of sanding here to take off any high spots. This is just some 240 grit, something I picked random out of my drawer. Let's get any high bits off. And I don't think I'm going to sand that. I think I'm just going to put the putty on there. All right, so that knocked off some of the highest spots, but there's definitely still some valleys in here, and that's what the putty's for. So I got a glove so I don't get the stuff on my hands. Let's take a little bit on my finger. And just rub it in. Sure, you can use a variety of tools. Probably a soft plastic one would be good here, or a rubberized one. So you just want to push it in. And I have only used this once before, so if anyone has any tips for using it, feel free to put them in the comments. And then the seam on the side here. All right, it's not pretty. Go ahead and let this cure, and then we'll go ahead and sand it back, and we may need to do another coat. We'll see. And this stuff stinks, so I'm gonna go ahead and put it outside. We'll be back once it is cured. I let that cure overnight, and we're looking to be in pretty good shape. I did a light sanding to go ahead and knock things back. I can see a few of the layer lines poking through, but I can't really feel them. This seam here I can feel a little bit more pronounced. I was using a paper towel and cleaning off some of the dust, and I'm getting a little bit of the kind of orangish red color coming through. So I think I'm going to go ahead and put a light coat of primer on, just to make sure that's all sealed, and that will give me one more chance to smooth things out. There we go, looking pretty good. I can still see a faint shadow where that seam line is, so I'm glad I did that. I'll go ahead and let this dry, and I'll give it one more sanding, and we can then move on to the next step. The paint is dry, let's go ahead and sand it a little bit more. And use some Scotch-Brite here to do a final pass. There we go, there is our inner mold. I think this will work out well for us. So now we need to go ahead and assemble the mold, and this is where I'm going to do a detour. As I mentioned, I usually use bolts and threaded inserts and this gasket, which is what these holes are for. So I would heat set the threaded insert, and then the other side would be for the bolt, and I'd screw this all together. But let's try using this tuck tape. I think it is going to work well enough. Off camera, I went ahead and I glued this together. So it's now it's one piece. So we still want to go ahead and align pieces. And I basically want to tape this down. All right, so there's a ring attached to the form, and we want all the tape on this side so we don't mess with the surface finish of the plaster. This should be easier to do. Let's put a couple pieces on for rough alignment. All right, that's once around all the seams. I'm going to go ahead and make sure this is all secured down and probably do another pass. But you don't need to see me do that. I'll just show you the results. All right, there we go. Tape on all the joints. I just took my wooden tool here and tried to make sure it was all secured down. So we need this to be plaster tight and to hold the shape. I think it's going to hold the shape just fine. Is it going to be plaster tight? I'm not so sure. I guess we'll find out in a minute. So our mold's all prepped. Is that easier than doing it the other way? Kind of, sort of. This tape's really wide, so getting it to go around the corners is a little bit tricky. It's particularly true on the bottom here, but also on the ribs on the side. Obviously this design was intended to be done with the threaded inserts, so I might be able to think about redesigning these flanges so they worked better with tape. That is a possibility. But before I went into all that effort on the software side, I wanted to make sure that, at least as a proof of concept, this worked okay. So I'm going to call that good enough for plaster. Speaking of, let's go ahead and mix up the plaster and pour it. So here's the README from Shapecast, and it basically tells you everything you need to do. So the thing we're interested in now is the volume of plaster that we need. So this basically says it's 1.5 liters of plaster we're going to fill up. It rounds that up for the dry plaster, 1.75 kilograms, and we need 1.22 liters of water. So it goes ahead and calculates the 70 to 100 ratio that we need. And like all good cooking shows, I went ahead and measured all that out. So here's the plaster, and here's the water. So what we're going to do is we're going to take the plaster and put it onto the water. That way we don't have any dry clumps in the bottom. If we did the other way around, the bottom layer would stay dry. We're gonna let it slake for 3.5 minutes. Let the plaster start hydrating without mixing it. Then we'll mix it for 4 minutes. And then we'll go ahead and pour it into the mold. I'm gonna put down some boards because I suspect this might leak. And I have this here. It's meant originally to be a flour sifter. I've used it to sift the plaster into the water. That way I do it nice and slowly. And there we go, there's all the plaster. I don't want to mix it yet, but I do want to get all the plaster down into the water. It's kind of floating. All right, we're done slaking. Let's go ahead and mix. And that's 4 minutes of mixing. Tap out some of the bubbles. All right, now we see if our mold is plaster proof or not. Exciting. I haven't done anything else to this. There's no mold release or anything else. It's just the print that we finished off. It's a nice thin stream if I can. Help break the bubbles going down. Plaster still nice and fluid, that's good. There we go. Had enough plaster, got a little bit left. Go ahead and tap this. One of the tricks I've seen, I've never tried before, is to use an old brush and to dab the surface. Make sure there aren't any bubbles there. And I see one tiny leak here and one here, but it's not all over the bench. Oh, there's another one right here, another one right there. Just tiny ones though. I can live with that. You can pull out an oscillating tool or sander or whatever and vibrate this. I think that'll help raise the bubbles to the surface. Just be careful you don't cause any cavitation. I'm not going to do it this time because I'm still not exactly confident in the tape. This will take, I don't know, half hour, 45 minutes to go ahead and set. In the meantime, I'm going to go ahead and get my water and alcohol mixture out of the freezer and clean up this plaster mess. The plaster is set. Now for the fun part, let's demold it. So this is where the tape should really shine. I can just cut it basically straight off. We did have a few leaks, but very minor, which is good. Was not prepared to deal with a plaster disaster today. There's the ring. Had a little bit more leaking than I would get than using the gasket, but I guess that's to be expected. Oh, jumped out. All right. So there's our mold. It's looking pretty good. Do have some bubbles, but they're all on this side so far. This recess here is where we lost a little bit of plaster. And get our seam line here. Again, this is a little bit worse than the non-tape method, but not bad. And non-functional. There we go. Now we have a nice smooth bottom. Make it nice to handle. So next up is to remove the inner mold. And usually just gently scrape away any plaster that leaked over the top. All right, and now to pull out the inner mold, and that's what this is for. This is a mixture of water and isopropyl alcohol. That means at freezer temperatures, basically 0 degrees Fahrenheit, no idea what that is, negative something Celsius, It's still liquid. Basically, it's as cold as you can get it at home easily. And it's still a liquid, or maybe a slushy. So we can pour that in here. There we go. So the alcohol makes it so that this stays liquid. And what happens when most things get cold, most things shrink. So basically that means that the PLA, the plastic, is going to shrink a little bit. The plaster actually expanded just a little bit as well, just part of the curing process. So by letting that sit for just a little bit, it's probably long enough, pour it right out. Put that in a bucket. I'll pour it back into the container and freeze it again later. Basically keep reusing it. Eventually I'll spill some and need to put some more alcohol in, but right now it's fine. Our mold came out just fine. So this can be reused. If you want to make production molds, you can make a bunch. And here is the slip casting mold. I see a little bit of colorant in there. I think that is from the putty. And you can see a little bit of a spot right there. We can go ahead and clean up the rim here a little bit more. And there we have it, a new slip casting mold. And we made a bit of a mess, but not too bad. The plaster will come right off. Got a trash can back here. Let's sweep all of this right into there. So these molds can be cleaned off, basically let them dry out, chip off the extra plaster, and in this case, go ahead and pull the tape off. I think the tape will come off pretty easily. So these molds can indeed be reused. I was really hoping the tape would be a more obvious win. Right now it seems kind of a wash. Maybe if you're a little bit more careful putting it on. The challenge is this tape's really wide, and so getting it to wrap around the corners is tricky. I went looking to see if there's something that's maybe half as wide. I didn't find it. So maybe an inch, 25 millimeters wide. I think that would probably be much better. This is meant to seal two sheets together, so I think it's wide on purpose. So it may not actually exist. It is super sticky and it is watertight though. So I'm not sure about using the tape in the future. I might try it again one more time, but the threaded inserts and the gasket seems to wind up with a better result. But if for some reason those don't work in your process, this is a viable option for sure. So I think we are well on our way to creating the hybrid. So here's the tall skinny one, and here was the shorter one, and here's our new one right in the middle. I need to let this go ahead and dry out, and then we can try slip casting a pot, but that will take a little while, so I think that'll be the next video. If you have any questions or comments, let me know. Thanks.